Jai Hind student, I am Dr. Anand Tyagi from Ajay Kumar Garg Engineering College, Ghaziabad. Today I am going to deliver my lecture on curve tracing, Engineering Mathematics First, KAS 103T. Before it, I explain here some portion of the curve tracing and how to draw the curve and how to calculate the curve tracing. And curve tracing is the most and important part of the engineering mathematics because area of the curve, volume of the curve is depend on this topic. So student keeping in the mind when we draw the curve, that will be the important and interesting part of our engineering and technology. Module 2 differential calculus 1 contents of the 2-day lecture are introduction of the curve and how to draw, that is curve tracing, and example based on the above topic, and recommended book of the Kreyszig Advanced Engineering Mathematics, Marais D. Ware, B.V. Ramanna and B.S. Grewal. Student can be opt any one of them for 2-day lecture. Now, first of all, what is curve tracing? Drawing the approximate shape of the curve by mathematically is known the curve tracing. And there are 3 types of curve tracing. First is Cartesian form. Cartesian form means, suppose equation in the form of y square is equal to 4x. Polar form means curve is depend on the polar form r and theta. And third is parametric curve. And how to draw parametric curve, this is play the most important role, how to draw the parametric form here, right? Question is that how to draw the parametric curve here with the help of the curve tracing. So I explain one by one. Suppose this is y square is equal to x, right? This is known as the Cartesian form, and this is known r is equal to 3 cos theta. This is polar form. And suppose I want to calculate here x is equal to 3 sin cube t and y is equal to 3 cos cube t. This is known as parametric curve. So today I explain one by one how to draw the curve tracing with the help of the some formulas, right? Student keeping in the mind, when we calculate the curve tracing one by one, we calculate easily, right? Now, how to draw the curve? So there are a special method that is denoted by the SOPAN. What is the full form of the SOPAN? SOPAN. How to calculate the SOPAN? We discuss here one by one here. S means symmetry. Symmetry means where does the curve exist and what is the role of the curve in the xy plane. This is elaborate with the help of the symmetry. Secondly, origin. Curve passing through the origin or not, that is the most important part of the SOPAN. And next is P. P means point of inflection, a point of intersection where curve exists and where curve intersect between 2 points. And another is the nature of the curve. That is the most important part, keeping in the mind when we draw the curve here, nature of the curve. And there are 3 types of nature, maybe cusp, maybe node and maybe conjugate. And another is asymptote. Asymptote play the most important role, and asymptote is a straight line which touch the curve at infinity. I elaborate in the middle of the lecture. And next, region. Where curve exists or not, this is depend on the region. If curve is exist in the real part, then curve exists, and curve does not exist in the imaginary part. Student keeping in the mind and remember it, curve does not exist in the imaginary part. Curve is always exist only in the real part, right? So I elaborate it today lecture very briefly, one by one, right? One by one, and calculate the value of curve here, right? I consider here symmetry. It means curve is identical, a curve is symmetrical about the initial line, right? If, first point, if curve contains the even power of y, that means curve is symmetrical about the x-axis. Suppose I have a curve here, y square is equal to x. So that means this curve contain even power of chi. When we draw the curve, so this curve is symmetrical, will be about the x-axis. That means curve play the most important role, and there is curve exist up and down of the x-axis. So in this way we find the possibility of the curve here. And secondly, right, I explain here another example, parabola y square is equal to 4x is symmetrical about the x-axis because curve contain even power of y here. Curve is symmetrical about x-axis. Student, keeping in the mind, if curve contain even power of x in the same way, then curve is symmetrical about the y-axis, right? Suppose we consider the another example here. This is the parabola x square is equal to 4ay and even power of x here, right? The curve is symmetrical about the y-axis. This curve is symmetrical about the x-axis and y-axis. This depend on the even power of x. We can say that if curve contain even power of x, then curve is symmetrical about the x-axis, and curve contain the even power of y, then curve is symmetrical about the x-axis. So in this way we can calculate the symmetry of the given curve by using the two postulate. And another postulate is that, right, suppose I have a curve here, right? If x is replaced by minus x and y is replaced by minus n, and there is no change in the curve, that means curve is symmetrical in first quadrant and third quadrant. That means curve is symmetrical in opposite quadrant. How to? Suppose we consider a curve here. In the place of x, I write here minus x, and in the place of y, I write here minus y, right? So what will be the result here? The result will be same here, x, y is equal to c. That means negativity of the x and y does not affect on this curve. So therefore this curve is symmetrical in the first and third quadrant like this, first quadrant and third quadrant. So in this way we can find out the position of the curve. We can say that symmetry of the curve by three ways. First of all, even power of x, right, even power of y, and symmetry about the first and third curve. And last and fourth symmetry, if x is replaced by y and y is replaced by x in the curve and there is no change in the curve, then curve is symmetrical about the line y is equal to x. And a student know very well what is the position of the y is equal to x line. This is the y is equal to x line. That means curve is symmetrical about both ways, in this region and in this region, right? This is the line y is equal to x, right? Suppose we consider another example here again, xy is equal to c. Suppose I write y in the place of x, so y, and x is equal to c, and both curve are same. That means this curve is symmetrical about the initial line y is equal to x. So we can say that curve is symmetrical about the line y is equal to x. So symmetry play the most important role when we draw the curve here. Now another is O. First of all we check that curve is passing through the origin or not. How to check? First of all we satisfy the 0, 0, that means origin, then curve is passing through the origin, otherwise not. Suppose I consider here y square x minus 2a, right, is equal to x cube, right? So first of all we check that given curve is passing through the origin or not, right? So suppose 0, 0 satisfy the this equation, that means we can say that curve is passing through the origin. In the same way, suppose I consider another example, xy is equal to c. So in this way, right, this curve is not passing through the origin, right? So we can calculate the condition of the origin and denoted by O. So in this way we can calculate the given curve is passing through the origin or not. If curve is passing through the origin, then we calculate the tangent at the origin, and there is a new method to calculate the tangent at the origin without using derivative, right? What is the method? Equating to 0 the lowest degree terms of the curve. That means curve is symmetrical about the origin and about the line, right? In this way we can calculate the tangent of the curve. Suppose I consider here y square is equal to 4ax, right, equating to 0 lowest degree terms of the curve. So this is the lowest term of this curve. Yeah, we can say that this is lowest degree terms of the curve. So we can say that 4ax is equal to 0 and x is equal to 0. That means y axis is the tangent at origin. So in this way we can calculate the tangent of the curve by using this method, and this method is very most important and play the most important role when we draw the curve tracing here, right? Another way we can calculate here, right, how to calculate the another point that is known as point of inflection. Point of inflection means suppose two curve intersect to each other, right? This, so this is point is known as a point of intersection, a point of inflection, right? So first of all we said that what is the role of this point. So first of all, putting y is equal to 0 in the curve and calculate value of x, say a comma 0, right? And this point will be on x axis. In the same way, right, putting x is equal to 0 and calculate the value of point y 0 comma b. So we can calculate further the point of this position of the x-axis and y-axis. Find the tangent of by shifting this point. How to calculate equating to 0 lowest degree terms. So this is the method to calculate the tangent of the curve at the point, right? Student, keeping in the mind when we solve the problem, right, if curve contain no power of fraction and tangent will be y-axis at a comma 0. That is the most important part, right? Without any calculation, we take the direct decision by using this note. If curve contains no power in fraction, then tangent will be y-axis at the point of a comma 0. In the same way, right, 0 comma b, what will be the tangent here, right? Tangent will be here x-axis. So in this way, we can calculate the tangent of the curve. And another and most important part of the curve tracing is nature of the curve. How to calculate the nature of the curve, we justify here, right? So first of all, right, there are three types of the nature of the curve: open node, closed node, and cusp, right? So what will play the important role? First of all, we check that. This is known as the open node, just like a tie when we denote it close together, right? And this is the close node here, and this is known as cusp. Cusp, just like a leaf of the tree, right? So in this way, there are three type of the nature of the curve, and another type of the conjugate of the curve, right? It does not exist in the curve. So first of all, we calculate here asymptote. What is asymptote? It is a straight line which touches the curve at infinity, known as a asymptote. And there are two types of asymptote. First is oblique asymptote and another is the parallel asymptote. So today I explain how to calculate the parallel axis and how to calculate the oblique. I explain in the next lecture, right? So first of all, we calculate the asymptote, parallel asymptote. How to calculate parallel asymptote? This is the formula: equating to 0 the coefficient of highest power of x in the curve, right? And this power will be parallel to the y-axis, right? Student, keeping in the mind, right? In the same way, equating to 0 the highest power of y, and that will be the parallel to the y-axis in this way, right? So I write here, suppose I have a question: x square x minus 2a, right, is equal to xy, right, cube. So how to calculate here, right? Right. So first of all, equating to 0 coefficient of y highest power is 3, right? And coefficient is x. That means x is equal to 0. That means y-axis is the asymptote of this curve. Suppose I write here another example. Suppose I write here y square x plus 2a, right, is equal to x, right? So highest power of y is 2 here, and coefficient of y square is x plus 2a. So that means x is equal to minus 2a is the parallel asymptote, and we can draw it easily, right? So when we solve the problem, we see very carefully. So in right, this is the procedure to calculate the asymptote of the given curve. And last is the reason where curve exists. Curve is always exist in the real part. Curve does not exist in imaginary part. So student, keeping in the mind when we solve the problem, so this softener is play the most important role, right? I take the example here: y square 2a minus x is equal to x cube. How to draw this curve? So first of all, we see that here symmetry, right? How to calculate a symmetry of this curve, right? So I explain it one by one. So first of all, I calculate here region. So first of all, we calculate the y in terms of x here, and we see that, right, y is real always between x greater than 0 and less than or equal to 2a. Suppose I want to calculate asymptote of this curve, right? So highest power of y is 2 and coefficient of this is 2a minus x. So x is equal to 2a is the asymptote of this curve. This curve passing through the origin, right? So in this way, we can find out the procedure and calculate the region and each and every terms of this curve, right? Consider here, right? This is very most important part of the curve tracing. If curve symmetric and tangent both are same, if curve have symmetry and tangent both are same, then nature of the curve will be cusp. That is the most important part. If both are different, the nature of the curve will be the node here. So student, keeping in the mind, this node play the very most important role when we draw the curve tracing, right? So we calculate here. So first of all, I explain here taking by example, trace the curve y square 2a minus x is equal to x cube. So first of all, we calculate the symmetry of this curve. This curve contains the even power of y. Therefore, curve is symmetrical about the x-axis, right? That means this curve can be sketched with the above and below the x-axis in this way. Another form is origin. This curve is passing through the origin because this curve is satisfy the origin 0, 0 here. So in this way we can calculate the origin of this curve. In the same way, right, equating to 0 lowest degree terms, right, and what will be the lowest degree terms? The lowest degree terms of this curve is 2ay square. That means y is equal to 0, and y is equal to 0 means x-axis is the tangent at origin of this curve. So in this way we can calculate the tangent of the curve. And another point is nature. Because tangent and symmetry both are same, so nature of the curve will be cusp at the origin. So in this way we can find out the nature of the curve, right, symmetry of the curve, and curve passing through the origin or no. So nature of the curve play the most important role here. Putting x is equal to 0 in the curve, then y is equal to 0, and putting x is equal to 0, y is equal to 0. So that means there are only 1 point 0, 0. And another point is asymptote. Equating to 0, the coefficient of highest power of y, this asymptote will be parallel to the y-axis. How to calculate? We explain here. So highest power of y square, and coefficient is 2a minus x. So asymptote is 2a minus x is equal to 0. That means x is equal to 2a is the asymptote, and this will be the parallel to the y-axis. So in this way we can obtain the asymptote of the curve. And finally calculate the region of this curve, and the region of this curve is y is equal to under root x cube upon 2a minus x, and this curve will be real here if x is greater than 0 and less than 2a, right? In this, that means curve exists in this region. So how to draw the curve? And finally here, by using this point, the student see very carefully, right? So first of all we see that, right, what will be the role here in this ray, right, this is the position of the cusp, and this is the asymptote x is equal to 2a, and curve exists in the this region, and this region x is greater than 0 and less than 2a will be the right hand side of the origin. So right, this is the position, right position and right curve tracing of this curve, and right of the given problem. So student, keeping in the mind of the softener is play the most important role. First of all, symmetry, origin, nature of the curve, in intersecting point, asymptote, and region of the curve where curve exists. In the same way, we consider here another example, xy square is equal to a minus x into a square, right? This curve contain even power of y here, so curve is symmetrical about the x-axis. In the same way, right, curve passing through the origin node, right? The curve is not passing through the origin because left hand side is contain 0 and right hand side contain the a cube, right? So we can say that curve no passing through the origin, and there is no tangent at the origin because curve is not passing through the origin. In the same way, right, putting y is equal to 0 in the curve, and we calculate x is equal to a, and this is the point lies on the x-axis. In the same way, putting y is equal to 0 and calculate the tangent of the curve, right? And tangent of the curve a comma 0 will be y-axis. I explained before it, right, how to calculate the tangent without any using the derivative, and this is the most important role, nature, because symmetry and tangent at a comma 0 both are different. So therefore, the nature of the curve will be node here. If both are same, cusp. If both are different, that means node. So in this way we can calculate the nature of the curve. And another point is equating to 0 the power of highest power of y, that means coefficient of the highest power of y, and asymptote will be parallel to the y-axis, that means x is equal to 0. So in this way we can calculate, right, the highest power of y, and highest power of y is this, and coefficient of this is x is equal to 0, and x is equal to 0 means y-axis is the asymptote of this curve. So in this way we can calculate the region of the curve with the help of this curve. So in this way we can find out the region of the curve and calculate the position of the curve. So y is equal to this, and x is y exists when x greater than is equal to 0 and less than is equal to a, right? So in this way we can calculate the where the curve exists here very carefully. So in this way, this is the point a comma 0 and nature of the curve at a comma 0 is node, right? And this is the asymptote of the curve, right? Y is equal to 0. So we can say that curve passing through this point. So in this way we can find out the nature of the curve and find out how to do the curve of the curve with the help of curve tracing. And all these problems are based on the curve tracing on the Cartesian form. And the another consider here y is right, y square is equal to a plus x and a minus x. In the same way, this is the same problem. In this way, first of all, we calculate the origin and calculate the symmetry of the origin, right? Curve does not contain the any constant terms, therefore it passing through the origin. And symmetry, right, x-axis about the x-axis. In this way we can calculate the tangent of this curve, and by using the right this curve equating to 0 lowest degree terms of the curve, and equating to 0 lowest degree terms is the x square minus y square is equal to 0. That means y is equal to plus minus x here is the tangent at the origin. So in this way we can calculate the asymptote of the curve, right? Asymptote of the curve means equating to 0 the coefficient of highest power of x here. So x square is equal to a minus x, right? In this way we can calculate a plus x is the highest coefficient power of y is equal to 2 and coefficient of is x plus a is equal to 0, and x is equal to minus a is the asymptote here. So in this way we can calculate the asymptote of the given curve and calculate the value of the asymptote here and draw the curve tracing here. So I calculate the region of this curve and calculate where curve exists or not. Finally, the picture of this drawing will be this, because this is the point a comma 0 here and tangent of this curve is parallel to the y-axis, and this is the asymptote, right? And at the origin tangent is y is equal to plus minus x, right? That means curve passing through this, and this figure is known as the closed node. So in this way we can calculate the nature of the curve and asymptote of the curve and tangent of the curve, and finally draw the diagram with the help of the Sopnar point. In this way we consider here another example here how to calculate the curve passing through the origin or node, curve passing through the node, right? With the help of this example, right? Symmetry of the curve and calculate originality of the curve and point of intersection. The point of intersection is this, and how to draw this point with the help of the calculation, right? So we can consider here calculate tangent at the origin and calculate this, and y is equal to plus minus x is the tangent at the origin. So in this way we can calculate the position of these 2 points a comma 0 and minus a comma 0 here, and tangent at a comma 0 will be here, right? And tangent of minus a comma 0 will be here, right? And tangent at the origin is y is equal to x here and y is equal to minus x here. So in this way we can calculate the exact diagram of this by using the curve tracing and Sopnar, right? In this way, student keeping in the mind when we solve the problem, this is the another problem I consider here many problem. The curve is symmetrical on the both axes because curve contain even power of x as well as even power of y. So we can say that curve is passing through the origin or not, right? So curve is passing through the origin, I write here, right? Tangent at the origin equating to 0 the lowest degree terms of the curve, and lowest degree terms of the curve is this x square minus y square is equal to 0, right? That means y is equal to plus minus x is the tangent at origin. In this way we can calculate the tangent at the origin. So student keeping in the mind when we solve the problem, right? So Sopnar play the most important role, right? These two tangent will be real and distinct, hence the nature of the curve will be node at the origin. In this way we can say that, right? Point of intersection, so we can say that there are 4 points of intersection, and first of all we draw the these points on the x-axis and y-axis, right? And calculate the final position of the curve, and this will be the final position of the curve, because this curve 0 0 0 comma a and 0 comma minus a, this is the 0 comma minus a and this is 0 comma a, and this is the tangent, right, parallel to the x-axis, because there is no power of the friction in the curve. That means position of the 0 coordinate will be the tangent. So 0 coordinate is x-axis, right? That means tangent is parallel to the x-axis at 0 comma minus a. In the same way, curve has no frictional power, The tangent at 0 comma will be x-axis here. So in this way we can calculate the tangent of the curve at any point easily and fastly, right? Suppose I consider here another example, right? So first of all we can check that symmetry of the curve, right? Curve contain even power of x as well as even power of y. So curve is symmetrical about the x-axis as well as y-axis. Any curve contain 4 types of symmetry, and any curve cannot be any one of them, right? Symmetry. Suppose I consider here y is equal to x cube here, right? So this curve is not symmetric any because it does not contain even power of x, it does not contain even power of y. So this curve is not symmetrical about the x-axis as well as y-axis, right? Suppose calculate tangent equating to 0 lowest degree terms, and this is the lowest degree terms of the curve y square minus x square, right? Because this has the degree 4 and this has the degree 2. So lowest degree terms means y square minus x square is equal to 0 and y is equal to plus minus x. In this way we can find out the point of intersection here, right? And finally we draw the graph by using the asymptote. Equating to 0 the coefficient of highest power of y, right? The asymptote is equal to x is equal to plus minus a here, and draw the diagram very carefully. This is the diagram because x is equal to a is the asymptote and x is equal to minus a is the asymptote, and this is the final answer of our problem. So in today's lecture I explain how to calculate the curve tracing with the help of the given Chopinard point, and another problem is tracing the x raised to the power 2 by 3 and y raised to the power 2 by 3. We see that very carefully. Given can contain the fractional power, and above the fractional power is even or odd. First of all we check that. First of all we calculate the symmetry. Given curve contain even power of x and y. So given curve is symmetrical both axes, x axis and y axis, because given curve is contain the even power of x and even power of y. I write here in this form: x raised to the power 1 by 3 square plus y raised to the power 1 by 3 raised to the power 2 is equal to a raised to the power 2 by 3. So given curve is symmetrical about the both axes because curve contain even power of x and y here, right? Another point, given curve is not passing through the origin, right? This curve is not passing through the origin. So we have no requirement to calculate the tangent at origin because curve does not passing through the origin. Now putting x is equal to 0 and y is equal to 0, we calculate x is equal to plus minus a, right? X axis, and this is the point. Putting y is equal to 0, calculate value of y, right? Very carefully. So where does the curve exist? So there are 4 points: first, second, third and fourth. This is a comma 0, and this is minus a comma 0, and this is 0 comma a, and this is 0 comma minus. There are 4 points. Now student, keeping in the mind nature of the curve at a comma 0, right? Because curve is symmetrical about x axis, right? And curve contain the fractional power of x raised to the power 2 by 3. So tangent will be here x axis, right? That means nature of the curve will be cusp here. In the same way, nature of the cusp here, and nature of the curve is cusp here, and this is also a cusp, right? And this will be the final diagram of this curve, right? And this will be the asteroid of the figure. In this way we can find out the problem, and I explain here one by one. This is the final diagram of this, and that is known as the asteroid of the mathematically, right? And play the most important role in the next lecture when we draw the curve, and I explain how to calculate the polar form of the curve with the help of the curve tracing. If today lecture student have any problem, so they can contact me, and I clarify their queries, and I hope today lecture student better understand and calculate the how to calculate the curve tracing. Jai Hind. Thank you all.